I'm back at it. Everybody should get the first one right. That is left 2, down 3, kind of slope, equal to 2. So left 2, down 3, rise 2, run 1, draw a V. Solving that thing. Just remember what's trapped in here is either 3x minus 4 or negative 3x plus 4. That's what's in there. So you're either 2 times 3x minus 4 equal to 2x minus 7, or you're 2 times a negative 3x plus 4 equal to 2x minus 7. And I'm not going to waste your time working that out. All right. Number 3 says write your answer as an interval. And it's the same methodology. I am going to clean the numbers up a little bit just because I don't like that. So I'm going to 5 both sides. So 2 times the absolute value of 5. Ooh, we have a problem. This has to be changed. Make that a 3. Make that a 3. Won't work without that being a 3. 2 times 3 times 5x, the absolute value of 5x minus 3 is less than 10x plus 25. Why did I have to change that? Because the x's were going to be in balance. Apparently that's something I forgot to fix. Maybe I'll remind you in class tomorrow to fix that. Maybe I won't. Anyways, we get to write two equations. 3 times 5x minus 3 is less than 10x plus 25. Or, you may not remember this, with the inequality symbols, you have to flip the you flip the inequalities only when you divide, because Miss Buckley told you so. So there's my equations. And I will work this one out. 15x minus 9 is less than 10x plus 25. Get those x's over there. 5x is less than, looks like 34. And this tells me that x is less than 34 fifths. Moving over here, negative 15x. I guess it would have been fine with a 2, wouldn't it? One of these things wouldn't have worked, but whatever. We're going to change it to a 3. Negative 15x plus 9 less than 10x plus 25. And just so we can do that rule that Miss Buckley told us, let's move that over there. Negative 25x is less than, what, 16? Divide by a negative, flip the inequality symbol. X is greater than negative 16/25. Still got some brain fog today. So let's take a look at this on a number line, because that's what you're supposed to think about when you write inequalities. We are greater than some negative number, which means we would shade right, and we are less than some positive number. This is where negative 16/25 might be on a number line, and this is where 34/5 might be on a number line. But we're less than that guy. They're both open holes because of the inequality symbolism. So the interval is actually pretty simple. Negative 16/25 to 34/5. Number 4, a regression was run to determine if there's a relationship between hours of TV watched per day and the number of sit-ups a person can do, and there probably is. Results of the regression were blah, blah, blah. Use this to predict the number of sit-ups a person who watches 12 hours of TV can do to 1 decimal place. Pretty simple. X is 12. So sit-ups as a function of watching TV, whatever, is negative 0.823 times a 12 plus 38.66. My guess is the person who spends 12 hours a day watching TV can't do as much as the person who doesn't watch TV. But there is a relationship. I mean, there's a reason they call you a couch potato. Nowadays, it would be time, just screen time in general. Apparently, they can do 29 sit-ups. Now, they want it the nearest 10th, oddly enough. 28.8 sit-ups. And I guess that is a thing with sit-ups, because I've done sit-ups, and eventually you get to a point where you're like part of the way up and you're like, no, I'm done. You didn't finish it, but you got through most of it. All right, based on the data shown below, calculate the correlation coefficient rounded 3 decimal places. So you're going to have to turn diagnostics on. So you're going to hit second catalog or second zero. All right. So second zero. And you're literally going to scroll down until you see diagnostics on. That's what you do. There she is. And you press enter. And then you're going to go through, you're going to put your X's in list 1, you're going to put your Y's in list 2. You guys are not doing anything else at this moment in time besides linear regression. Oops. I'm going to look at the data itself. I'm going to hit second stat plot, make sure she's on, do a zoom 9. That is linear. It's really good too. Stat, calc, linear regression. If you have anything in frequency list, you have to get rid of it. It needs to be blank. Your screen needs to look like this. Calculate. And according to my TI-84, the R value is 0.9924. And they just wanted 3 decimal places, so 0.992. Easy problem. US import of wine in hectoliters. That's a weird one. What's a hectoliter? I know what it is. Do you? That's why I said it's weird. For several years as given below, determine if the trend appears linear. If so, and the trend continues, in what year will imports exceed 12,000 hectoliters? What a weird measurement, a hectoliter. Whatever. So, I guess we'll throw it in. You have options here. You can let this be year 0 if you want, but you're using technology, so I wouldn't even mess with it. Stat, edit. Was that 2000? Apparently we like our hectoliters of wine. Something happened between 94 and 96. Americans started drinking a lot more wine. Liberals. There's a jump. Well, that was fun. All right, there she is. The R value is high. The R value is like ridiculously high. And if I do a zoom 9 and look at it, it's linear. A case could be made that it might be exponential, but it's linear. So it does appear linear. I'm going to do something a little different on this one just because I can. Let's see here. I'll go back to stat, calc, linear regression. And you don't have to do this, but you see where it says store regression equation? You can hit the variable key, vars, Go scroll over to y-vars, hit function, and y1. What that's going to do is it's going to take your equation and put it into y1. So this stuff right here, as soon as you hit graph, is right there. Now I want to know in what year will imports exceed 12,000 hectoliters. So I'm going to go to Y2, I'll clear out all this stuff I had in there earlier, and I'm going to put 12,000, and I'm going to hit graph. And of course I don't see anything, because 12,000 is way on up there, isn't it? So I'm going to set the Y max to be something like 13,000. And I need to look to the right. Where's my line? Oh, I cleared my line. Fudge. Let me go through that process again. Vars, Y variables, function, Y1. And I didn't hit calculate. I should have just wrote the function down, shouldn't I? Try this again. Now the line's there. I cleared it. I should have put the 13,000 in Y2. Sorry, 12,000 in Y2. I just need to quit. And I need to look to the right. So let's add 100 years to this. So you see here 2100. There's an intersection. Second trace 5. That X value is crazy. It's at 2000. There we go. Enter, enter, enter. It looks like the year 2017. 2017, Americans will import 12,000 hectoliters of wine. Number 7, in 1994, the moose population in the park was measured to be 3140. By 97, population was 3440. We gained 300 moose. If the population continues to change linear, blah, 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 find the formula. So you're going to find your slope. We rose by 300. It took 3 years. It's 100 moose per year. All right. We're going to let 1994 be year 0. Notice they talk about since 1990. So this is year 0. So the population's function of time is simply 100x, or 100t, sorry, 100t plus 3140. When does your model predict, which is extrapolation, what the moose population will be in 2004? I mean, 2004 is 14 years after 1990, so time is 14. So it's 100 times 14 plus 3140, which is going to be 4540. 4,540 moose? I don't know. Let me go ahead and stop this one so that the videos aren't so blasted long.